All right, question 4 is another standard in the AP Calculus test. On the AP Calculus test, I took this directly from the 2018 test published online at the AP College Board website. We've got a table of values there, time and h of t measured in meters. The height of a tree is given by a twice differentiable function. Selected values of h of t are given in the table above. Again, part A is always going to be, let me just grab your hand and slowly walk you through this. Part A shouldn't be that difficult, and I'm assuming that this time it's going to be that same way, but it's tough to make these assumptions in these COVID times. Part A is asking us to simply estimate h prime of 6. Well, there's no way to actually evaluate h prime of 6 because I don't have the function, but I can evaluate that or estimate that because I can just do the slope as long as we know what a derivative is. I can easily see them asking this. This is basic knowledge. They're going to ask a lot of basic knowledge stuff. So with a table of values, since I want h prime of 6, I'm going to go ahead and utilize these two coordinates right here, the 5, 6, and the 7, 11, because that will help me find the slope. And slope is just simply going to be basic old school algebra slope, y2 minus y1 over x2 minus x1, 11 minus 6 over 7 minus 5. And if you work that through, you will get 5 over 2. You can leave it as 5 over 2. You can write it as 2.5. I would just leave it as a fraction. But then don't forget the units. The numerator is measured in meters. The denominator is measured in years. So that's 5 halves, 2.5 meters per year. And then we just have to explain what that means. That is because it's a rate, how fast the height of the tree is changing. And they said specifically to use units. And so it's going to be how fast the height of the tree is changing in meters per year. Make sure you put the units in your explanation. You don't want to lose points because you didn't put it there, even though it's in your answer. It's good to have them in the explanation as well. Okay, very, very straightforward, so you're not going to get a ton of points, but you will get a couple here. Nope, sorry, yes, you do. You get 1 point for the answer of 5.2, 5 halves meters per year, and 1 point for your explanation. We should have those 2 points. That's on every single, has been on every single AP Calculus test, a table type problem, and usually they ask you to find the slope in some fashion. So let's get those points. Let's say that we're going to get those. Now, Part B is challenging. Part B isn't a lot of work, but Part B takes a lot of thought, and the thoughts are usually much more difficult, right, than just straightforward work. Part B is asking us to prove why there must be a certain value over a certain time frame. We need to show that h prime is going to equal 2 sometime between 2 and 10. When you see things like this, that should instantly trigger either mean value or extreme value, or intermediate value theorem. It's going to be one of those two. Usually it's mean, but don't throw out the intermediate value theorem. If you recall the mean value theorem, we got to have a continuous differentiable function and on a closed interval. This interval, should be closed. There we go. And so that's locked in. I know h of t is differentiable. It means it's continuous, and so we just need to figure out if there's ever a time where the slope is 2. We don't necessarily want to use the values at 2 and 10. If you try using the values at 2 and 10, you won't get a slope of 2, and that's why this one's tricky. We can use any values between 2 and 10, and so if you glance through that table, if you take a look, if we use h of 5 and h of 3 and calculate those that slope for those two coordinates, clearly from the table we can see that h of 5 is 6, and h of 3 is 2 over 5 minus 3. That works out to be 2. So it doesn't have to be at the end points 2 and 10. It just has to be anywhere in between, and we do have a slope of 2. And so we want to make sure we say by the mean value theorem, and you never have to write out mean value theorem. Everybody in calculus knows MVT is the mean value theorem, the most valuable theorem, mean value theorem. And by the mean value theorem, we want to make sure that we say, since h is differentiable and continuous, and we know a slope, and we calculated the slope, we have a slope of 2, h prime of t's got to equal that slope, right, by the mean value theorem. So I'm also going to say, and the slope between 5 and 3 is 2. I'll say t equals 5. And t equals 3 is 2. H prime equals 2 for sure. Points for this one, pretty straightforward. Notice there wasn't a lot of work, but you still get a couple of points for this one. You get a point for realizing you needed to utilize 5 and 3 to figure out that slope, and then you get a point for somehow correctly stating the mean value theorem. As long as you've somehow stated the mean value theorem in some type of correct form, you'll get that point. So that's not too bad. They like to use the mean value theorem. I would be prepared for the mean value theorem for this test. That's old school. They're weighting heavily on the stuff we did first semester. So I would focus on the mean value theorem and make sure we know how to use that. Part C is also straightforward. Let me just get a line in here and divvy that up. There we go. Part C is asking us to find the average value using a trapezoidal sum. We have to be really, really careful. A lot of students a couple years ago didn't get full credit for this because they didn't read that they needed to find the average value. They just saw trapezoidal sum, and so that's all that they did. Remember, if you want to find the average value, which is what we're doing, we're finding the average value of h, we have to use the formula, and that formula requires us to throw in a 1 over b minus a, and then we'll multiply by the integral. If you forget that 1 over b minus a, you're going to have a very, very wrong value. You're not going to get full credit. So make sure you're reading the problem. Don't just read part of the problem. We don't skim problems. We read the whole thing. So we're looking for the average value of this function from 2 to 10. And so 1 over 10 minus 2, that's going to go out in front. And then we're going to integrate from 2 to 10. And to do that, we're going to do a trapezoidal sum. We can easily do the trapezoid rule. I would be prepared for the trapezoid rule. It's not too bad. And so that 1 over 10 minus 2 becomes 1/8. Our trapezoids all have a 1/2, and so I could factor that out as well. In fact, let's do that. So instead of having a 1/8 out here, let's make that a 1/16. So I factored out all the 1/2. So you can keep the 1/2s in there. It doesn't really matter. And so now I'm just going to do the heights. The first height from 2 to 3 is 1, so that's going to be 1, and then we've got 1.5 plus 2, etc., etc., etc. So I'm going to go ahead and get the rest of the trapezoid rule up here. And so, poof, like magic, there it all is. There's the values of everything. It works out to be 263 over 32 if you keep it as a fraction. If you go decimal, 8.21875 is the actual real decimal. You're not going to have a calculator for this, although with your test, you're going to have a calculator for all of it. There's not a calculator non-calculator because they can't police that. So you could have punched that on the calculator, but if this were the actual test, you wouldn't have come up with that decimal because you would have done that all by hand. So you would want to go 263 over 32 meters. Make sure you get meters in there. As far as points are concerned for this, not a ton, because it's not a ton of work. It's not a heavy problem at all. You get a point for somehow showing you're doing the trapezoid rule. If your trapezoid rule is wrong, but it looks like trapezoid rule, you'll get that point, and then you get a point for the right answer with the correct units. Make sure you get the right units in there. That's 2 points we gotta have. You can't miss the trapezoid rule. It's a relatively easy process. And so that's going to take us and move us on to part D. I can't fit part D here, so let's move to another slide. All right, new slide for part D. In part D, we have this function g of x. They're saying g of x represents the height of the tree. And so this 100x over 1 plus x, if we were to plug in 2, 3, 5, 7, 10, we should get those y values. So g of x is the same as h of t. But we actually have the function. X is the diameter of the tree. So I couldn't actually, a mistake. I shouldn't say that. I can't plug in these values because those values are time. X is the diameter, which is totally, totally different. I know that when g of x equals 50 meters, when the height of the tree is 50 meters, dx dt is changing at a rate of 0.03 meters per year. That's how fast the diameter is changing. We are looking for the rate of change of the height of the tree. So in other words, we want the derivative of g of x, but we have to be really, really careful about what x is, what t is, what h is. That can get really, really challenging. So first, we know that we're looking for the rate of change, so we should at least take the derivative. dg dt, that is simply going to be a quotient rule. That's not too bad. So if we do the quotient rule, we'll take the denominator, 1 plus x, times the derivative of the numerator, which is 100, minus the numerator, which is 100x, times the derivative of the denominator, which is just 1, and all of that will be over our denominator, 1 plus x, quantity squared. Now, if you just stop right there, you have forgotten, very, very important, the chain rule. This is implicit differentiation. We're looking at how things change based on time. Our variable is x, and so I have to multiply by how x is changing. I have to multiply by dx dt. Don't forget that portion. You could clean that up. I'm not even going to bother cleaning it up. I'm just going to leave it just like that. Now we just need to plug in things. I know dx dt. It's given to me. It's right there. dx dt is 0.03, so that's going to be easy to plug in. Here's where we're going to trip up. Many of us might go, oh, I'll plug in 50 for x. That does not say x equals 50. That says g of x equals 50. It's the height of the tree. X is the diameter. We weren't given that. So what we need to do off to the side, and do that in a different color, we need to figure out what the diameter would be when the height is 50. So I'm going to go ahead and take g of x and set it equal to 50 and solve for x to figure out what the diameter would be that would create a height of 50. So we've got 100x over x plus, 1 plus x. Setting that equal to 50, I would set it equal to 50 over 1 and then cross multiply and work it through. I'm not going to do all the math there. I'm sure you can handle it. You'll get that x is equal to 1. That's what we're going to be plugging in. So we'll plug 1 in for x, we'll plug 0.03 in for the dx dt portion into our derivative, and then we should be all good. And so just showing you what that looks like when we plug in 1 for x, 1 plus 1 in the parentheses is 2 times 100, minus plugging 1 in for x, that's just going to be minus 100, over plugging 1 in for x, 1 plus 1 is 2 squared is 4. And then we don't want to forget to multiply by dx dt, which is 0.03. And if you do all of that work and work it out, that should come out to be 0.75. And as far as the units are concerned, it's how the height is changing. Meters would measure the height. It's changing per year because that's the time in the problem. And so we get 0.75 meters per year. As far as points are concerned for this problem, you get a point for doing the derivative of g of x by doing the quotient rule. You'll get a point for remembering to throw on that dx dt, and then you'll get a point for the right answer with the right units. So if you forget the dx dt, you're only getting 1 point out of 3 here. Don't forget that. That's very, very important. Otherwise, this problem isn't too bad. I would plan on having a problem like this. I'm thinking a problem like this will be there. They like these types of problems with tables and all of this stuff that we just covered. So until next time, have a great day.